All right, y'all, we're going to do a quick review on domain. So when we say domain, we mean the set of all possible inputs, typically x, for the function. So domain is usually any number we like from negative infinity to infinity, so all real numbers. The exception is if we break one of these two rules. So this is what we're going to look out for. We are not allowed to divide by 0, and we don't take the even root of a negative. So the square root of a negative is not going to be defined. These are not the only two rules. We'll add to this later, but for now, this will get us pretty far. Okay, so let's look at some examples here. So here we just have a linear function, y equals 2x plus 3. So again, we assume our domain is all the numbers unless we are going to do one of these things. So there's no division here, and there's no square roots. So the domain is all numbers. Looking at the next example here, we have a quadratic. Again, there's no problems, no division of x, no square roots of x. So our domain, again, is going to be all real numbers. So most functions won't have any domain issues, but let's get into some that do. Here we have this rational function, 1 divided by x. And again, we have the rule that we cannot divide by 0, which means we could make x any number we want except 0. X cannot be 0 because that would break our divide by 0 error. All right, 1 divided by 0 is undefined. So to write that in interval notation, we're still going to go from negative infinity to infinity. We're going to have to leave a little gap at 0. So that would look like this. Okay, let's make that a little bit harder. So same idea here. We are dividing by some x's, but now it's a lot harder to figure out what x would make the bottom 0. So here's where we're going to use some algebra skills. I'm going to take my denominator. We don't really care about the top right now. So just going to take the denominator and try to figure out when is this 0. Okay, this is not allowed to be 0 because then we would be dividing by 0. Okay, so this one's going to take a little more work to figure out. If we factor this, it'll be a lot easier to figure out what numbers are going to cause problems. So we can use our box or our diamond method here to break this down. We got to multiply to get 10, add up to 3, and the 10's negative, so they're going to have opposite signs. All right, so I got plus 5 and minus 2 when I factor this. And now I can see that there's two numbers that are going to cause this to be 0. If I plug in a 2 right here, we get 0 times 7, which is 0. If I plug in a negative 5, we get 0 times negative 7, which is 0. Okay, so these are the two numbers. X cannot be negative 5. X cannot be 2. So when we write our domain, we're going to exclude these two numbers. So that's going to look like this. All the numbers from negative infinity to negative 5 are okay. Negative 5 to 2. Don't forget the numbers in between. And from 2 to infinity. So all the numbers, and then we just have these little holes at negative 5 and 2. If you were to take a look at the graph, we would see we'd have two gaps at those two numbers. So you can verify all this in Desmos. Okay, so that's what happens when we divide by 0. There's a couple examples for that. Now let's take a look at that square root rule. Okay, so any even root, like a square root or a fourth root, we're not allowed to have negatives in there, or we end up with non-real numbers. So let's take a look at this first one. Y equals the square root of x. Again, we cannot take the square root of a negative, so x has to be 0 or higher. Note that we can take the square root of 0. That's 0. So that's okay. But anything negative is going to cause problems. So x has to be any number 0 or higher. In interval notation, we could write it like this. 0 to infinity. Note the square brackets. 0 is okay. We just showed that exactly 0 works. So we're going to use square brackets to include that number. This one is the same idea, but a little more complicated. So we've got the square root of 2x plus 5. So same idea. The thing under the root has to be non-negative. So I'm going to take the radicand, that's the thing under the root, and say that has to be at least 0. And then we can solve this equation, or inequality. Inequalities work a lot like equations. We can solve them doing some algebra steps. Oops. There are a couple rules to watch out for when working with inequalities. If we ever divide or multiply by a negative, the inequality would swap around. It didn't happen this time, but it's something to look out for. It might be a good idea to, anytime you work with an inequality, to plug in some numbers to make sure you are pointing in the right direction. But I'm pretty confident this is x has to be bigger than negative 5/2, or you could think of this as negative 2.5. Okay, so anything bigger than negative 2.5 is okay, including negative 2.5, which we're going to keep as a fraction, negative 5/2. Okay, so there's my domain. Again, square brackets are important here because negative 5/2 is okay. One more example here. Now we have a cubic root of 3x minus 1. So these before were square roots. When we don't see a number in the index, is what we call that, we assume it's a 2, because square roots is what we use most often. But we do have other types of roots, third roots or cubic roots. We have fourth roots and so on. So I have a cube root of something, and note that my my rule only applies to even roots. So a cubic root function is unlike a square root. A cubic root function will go on forever in both directions, whereas a square root function is only going to go in one direction. So this actually has no issues. Our domain is all real numbers.